let me ask the question of the group that's here, just to get an idea of what familiarity level you have with PixInsight. Um, how many people are what I'll refer to as very frustrated newbies with PixInsight? I see one hand up. Hi, Doug.
Oh, I'm not a newbie. No, sorry. Is there a way to vote on this?
There probably is. I don't mind if people just yell out. That's
I'm I'm not a newbie, but sometimes I get frustrated.
yeah, I know that feeling.
I'm a newbie, for sure.
Okay,
Yeah,
And I'm a total newbie.
fair enough. Okay,
I'm a newbie.
well, there are now enough newbies out there to make it worthwhile. I'm assuming going through at least briefly the user interface in PixInsight. So I'll start there. I'm assuming again everyone can. What's that? Okay, I'm assuming everyone can see my screen here. And one interesting thing about PixInsight is it is not a Windows application, it is not a Mac application, and it is not a Linux application. It manages to piss off users of all three operating systems. What's that? Yeah, when it was written using, oh, I forget which user interface system now, but believe it or not, it has won some awards, and it did take me a while to get used to. Was a diehard Images Plus user. Images Plus is getting a little long in the tooth, and I wanted access to some of the newer tools. So about 2 years ago now, I migrated to PixInsight and have slowly been working my way through all the tutorials that I managed to find. And we decided we'd run a few sessions to get people up to speed in PixInsight for the Halifax Center here. And once we had managed to pick a time, and I realized the time is not necessarily convenient for other centers across the country. That is the problem when you span 4 or 5 time zones. We decided we'd open it to the entire RASC. So we'll start there. So PixInsight, it has the usual, and I'm going to say GUI type interface, several menus across the top, quite a few buttons on the toolbar here to let you do various things. All of those are controllable through the view menu. You can turn on, various toolbars, turn on your favorite ones, turn off the ones you don't use very frequently. What I find is I tend to use quite a few of the toolbar buttons. And my problem is I can never get enough resolution on my monitor to show as many as I want. Down this side, you have Explorer windows. Now, I'm going to highlight a couple of them here. Bear with me. There's the process console. So as PixInsight carries out commands, it will send feedback to this console. You can also type commands on that console. I don't tend to work that way myself, so I have not done a lot of work to see what's available for typing in those commands. There is the Process Explorer, which is another Explorer window that I leave open. And it's convenient for finding specific tools. Now, it's very easy to find tools in PixInsight, but this one in particular, if you remember the name and just don't remember where it's put, you can search for it just by typing its name in here. The other route that works quite well for that is if you click Processes, and in this process list, there is sort of an itemized list. So all of the deconvolution routines appear under deconvolution. The one problem is if you don't remember where they appear, it can be a bit of a pain to find them. So they have an all processes category where it just lists them alphabetically, which is what I end up using most of the time. It's just quicker than going over to the Process Explorer. One thing about the Process Explorer is it is a convenient way to get to the documentation when it's available. If I can find some, here we go. So if you click on a process, the documentation for that process will show up in this window when the documentation is available. Not all tools are documented to the level that you would like. Some, as you can see here with TGVDenoise, are not documented at all. The web is your friend when it comes to a lot of the PixInsight tools. There are a variety of other Explorer windows that you can turn on. One of the most useful is the History Explorer. And if you take a look, it's down here at the bottom. And as you work on an image, the things you've done to the image will show up in this Process tab. You can move back in the history. You can change the settings for a given command. However, there are things you have to do to then reapply the rest of the steps. It's not as convenient as some other history windows in other applications where I can go back and change a setting and then just click next instruction and it'll do the next thing on the list. You can do that in PixInsight. You just have to do it a little differently. File menu is the usual stuff for most file menus. You can open a file, you can open a copy, you can open a location and browse through and get what you want. There's a recent list, you can clear the recent list, you can save as. You can save a project, which is quite useful if you're in the middle of doing something and have to stop for any reason, or you want to come back to it later. Later being much later, because you can always just hibernate your computer and pick up where you left off. But it saves everything. So the image, what's been done to the image, any other images you used, masks, that sort of thing, they're all saved. So the project file can get quite large. So watch out for that if you have limited disk space, but it is very useful to save a project and reload it later. Edit, pretty straightforward. You can, edit, copy from the clipboard, those sorts of things. But the most useful thing under here is pretty much the global preferences. So this lets you set all of the preferences for PixInsight. And under global preferences, you get to, set how your main window is going to look, your UI resources, all sorts of things. Some of the most useful settings, for instance, is, oops, wrong one. I apologize, directory and network settings. In here, you can set the number of swap files and where they're located. Now, PixInsight will use swap files, and if you don't tell it to and you're running Windows, it will use the general Windows swap file. I would caution against that simply because in a lot of cases, unless you happen to have a solid state drive for Windows, for your Windows install, it may go to a normal hard disk as opposed to a solid state disk, and they are considerably slower. It is well worth, if you've got a solid state disk on your machine, putting your swap files on that solid state disk. A bunch of other settings here as you go through. Another one that is quite useful, if I can find it, is the thread settings. Here we go. So here I can set the maximum number of threads or processors that the system will use, the maximum number of reading and writing threads. And if you're fortunate enough to have a NVIDIA graphics card, you can enable acceleration for some of the AI tools that are now becoming available. Unfortunately, my machine uses Intel graphics, and that means that my AI tools will run a little slow. So you will have to bear with me tonight as I give people a look at some of them. They may run a lot slower than you're used to. Um, the machine has 14 cores and it'll use them all for that, but it's nowhere near as fast as a decent graphics card. View, we already took a quick look at. You can control which Explorer windows are available. You can toggle the process console on and off. You can open up a script editor. We, in a future session, may get to touch on scripting in PixInsight. I haven't done a lot in PixInsight with scripts just yet. So once I figure it out, I'll let folks know. There are real-time preview windows that you can turn on and off, toolbars, all that sort of thing, and zoom in, zoom out. Although generally speaking, I use the toolbars or my mouse wheel for that. The image window allows you to do things to any given image. So I can do an undo, a redo, undo all the usual things. I can convert color spaces. Okay, I can extract channels. I can also, this is where the geometry setting is located. If I want to rotate a window or mirror the view, it's in here. It'll let me do things like rescale, color management once I set it up. It is set up on this machine, fortunately. So it's got quite a few functions here that I've never used. And tell you the truth, I will plead totally ignorant and say I'm not sure what desynchronize all in current workspace does. The preview window, I'll come back to that one in a minute. Come on, mouse, there we are. So we have a mask window that will let me select a mask, remove a mask, invert, enable, and show the mask on a given image. That is also available through a right-click speed menu, which is what I tend to use most of the time on a given image, and we'll look at that in just a minute. We already took a quick look at the process menu. It's a categorized list of processes, and it also has all of the processes listed alphabetically.
How did you get those processes to show like that in 3 columns instead of I just have mine in 1 column. How did you do that?
It's just the way it came up on this machine.
Oh.
There's probably a global setting to make that happen. I'm assuming when you say you just have 1 column that you have to scroll up and down in the column.
That's right.
Yeah.
Which is a bit of a
Are you a
pain.
Mac user?
Yes.
Yeah, that's why.
Oh.
Sounds like that's a Mac thing.
Yeah, that's a Mac thing. They do not fold automatically on the Mac.
Yeah, I can vouch for that.
Okay, too bad. Okay.
Yeah, but in Windows, at least, they will fold and give you as many columns as it takes to fill in. We can go through each of these. It's really not worth doing at this point. As we work on some images, we'll go through some of these and give you an idea what they do. The script menu item gives you access to an ever-growing list of JavaScripts that are written for what is it now? It's the J8 engine, I believe, in the latest release of PixInsight. I downloaded and installed that list, and it broke all the scripts that I had. So I rolled back, and I'm just waiting for all the vendors to catch up, and then I'll reinstall the latest version of PixInsight. But give you an idea, here are some of the astrometry settings. So this is where the image solver lies. Someone asked earlier what to do if you can't solve an image. We'll cover that in a future session. basically what I tend to do is just get very frustrated with it and poke at it until it works. Then, there's from various different suppliers. SetiAstro is one of my favorites. Here are all my SetiAstro scripts, and any SetiAstro script other than, no, even Cosmic Clarity is there. There we go. They get downloaded here. The package ships with a toolbox menu and a utilities menu. Again, all scripts. You can see those scripts anytime. You can actually go to the scripts directory and edit them as text files, but there's actually a scripting editor built in. You can see it right here. Workspace. One nice feature that I use to keep my workflows somewhat uncluttered, because if you've worked in PixInsight for any length of time, since it doesn't support layers, you'll have noticed that you tend to have a whole bunch of images open and it becomes a real pain to find the image that you want. What I generally do is I will take my images and break them up. So for instance, any masks that I'm using, I'll just stick on another workspace and you can select the workspace here. The workspaces show up down here. There are 4 by default. You can add others. And so I'll have images on one workspace, masks on another workspace. The workspaces are not like Windows workspaces in that they're not totally isolated. So I can be in one workspace and use an image or a script or anything else from any of the other workspaces. You can also select images from any of the workspaces on this menu button, or not menu button, this drop-down list right here. It gives you a list of all of the images that are open. When you click it, you can scroll up and down and select the one you want. Window is pretty straightforward. You can cascade windows, tile windows, all the usual things. And the Resources tab is actually fairly useful for a number of things. Chief amongst them is this is where you set up repositories to download the scripts and processes that you want to add to PixInsight. One thing that PixInsight did that is very nice, the platform is somewhat open, so users can write processes and scripts, make their own, and make them available to other users, which is what a lot of people have done. And with that, I'm going to open an image here. Bear with me. Open a copy. Okay, I'm going to take this one. Now, this is, once it opens, I close down that. There we go. So this is an image of the fireworks galaxy, and I'm sure everyone can see that it isn't right there. It actually is. And the reason I opened it this way is I wanted to give everybody an idea of one very nice function, and I'm sure all the people that are familiar with PixInsight know all about it. It's called the screen transfer function. Now, in another package that I've used called Images Plus, Mike, the gentleman that wrote it, Mike Unsold, didn't believe in screen transfer functions. And it was a bit of a pain because you had to stretch an image to see it. And of course, you can't figure out how much you want to stretch it or deconvolve it before you stretch it, which becomes a chicken and egg thing. PixInsight includes a screen stretch where it only stretches the data that's visible on your screen. It does not apply it to the data itself. So you can use it to look and see what your image looks like before you do anything to it. So screen stretch is turned on with this button. You can access it under intensity transforms. Right at the bottom is screen transfer function. You can access it from the process console. It's probably high up on my list here somewhere. But once and you can access it with this button, which is very useful. So I have the screen transfer function turned on, but not yet applied to this image. If I click this button, this will apply the screen transfer function. Now you'll notice that the image is, in my case, very green. There's a reason for that, in that my camera is more sensitive to green than any other color. I work with a one-shot color camera. And the screen stretch, as applied to a color image, calculates the stretch statistics per channel. So it says, oh, I can stretch the green even more, and you end up with this wonderful green image. If instead you hold the control button on your keyboard down while you click this stretch, it unlinks the 3 channels and it stretches each one separately. So if you take a look, I'm just going to bring up the screen transfer function here. Here's the screen transfer function. Here's the link. So all 3 channels right now are linked. If I turn that off and I stretch it again, now you can see much more of the image and what it actually looks like. The channels no longer receive the same stretch. So it calculates them all individually. It's almost a must when you are starting your image processing, because if you don't do that, you can't really see any gradient in that image. It's all masked by the green. So if I unlink the channels and do a screen stretch, now I can see what's going on in this image. Sorry, was someone asking a question there? Nope. Okay. Some of the other things in the screen stretch that are very useful, if you hold the control key down and you click on the nuclear button, you get the auto stretch settings for the screen stretch. So this allows you to vary the statistics that are used in the screen stretch. I can, for instance, change the shadows. And if I just click OK, and now you saw what happened there. The image is no longer stretched as much. I can, where'd it go? Here it is. I can target a brighter or a dimmer background, so I can dim the background down as an example. Now you see the background got quite a bit darker. These are all the things you can do with the screen stretch without having to try and move the sliders, which can be a little hard to get to from time to time. You can zoom in. Now, on this zoom button affects the display here. So for instance, if I zoom in here, you'll notice that on this channel, I'm stretching the display so I can see the sliders. And I can reset that. There we go. There's a usual tool button that this is some of the screen stretch transfer properties or parameters. You can play with them, get what you want. You can reset them back to normal, and there's your image. You get the idea. So the screen transfer function is very, very useful when it comes to displaying your data before you have done anything to it. I'm just going to reset everything in the screen stretch here so it comes back to normal, which it won't do until I reset it. There we go. So the other thing that comes in handy here, so you can see the galaxy now. You'll notice that the galaxy is embedded in a very rich star field. And before we're done tonight, I'll go through a brief workflow that will show you how to bring that galaxy out even in that dense star field. Okay, so any questions so far on screen stretch? Remember that it's not applied to the data. It's only applied to the view on your screen. Okay. Now, there are a couple of plugins that, and show of hands here, are Are people familiar with the SetiAstro Plugins, Noise Exterminator, and BlurXTerminator?
No.
No? Okay. Um,
Yeah.
I hear some no's and some yeses.
Yes.
Yeah, the yeses are from people who have worked with PixInsight for a while. I suspect the no's are coming from people that don't have a whole lot of experience with PixInsight. And bear with me, I'm just going to move a window over here. PixInsight has functions for reducing noise. It has functions for doing deconvolution. They are cumbersome to use at best. With the recent developments in AI, the folks at SetiAstro have developed two exceedingly useful tools called BlurXTerminator and Noise Exterminator, and I'm going to use them tonight. You'll get an idea of what they do. They take a little bit of time to number crunch, but the results are fantastic. They are well worth the effort required, or the cost rather, required to buy them. They're not outrageously expensive. And I would highly recommend getting them for your processing. It will save you so much time and frustration when it comes to doing things like deconvolving and noise reduction that you'll wonder why you haven't had them. You'll wonder why they're not simply sold with PixInsight. And the guys at SetiAstro want to make their fortune selling them as well, but they are reasonably priced, so they're well worth it. And we're going to take a look at one of them right now. As soon as I turn off, sorry. There we go. So, my buttons are not linked. Bear with me. I have to bring them back. Relink everything. There we go. So, here's a simple screen stretch applied to the image that you see. And I'm going to brighten that image up just a little bit. Bear with me. Target the background back up a bit. There we are, a little brighter in the center. I can see it now. So again, what you want to do is you want to initially, assuming your camera is like mine, where it's more sensitive in one channel than the others, you want to turn the screen stretch link off. Wrong button. And then apply a stretch to the image. Now you can see where things aren't quite right in this image. And if I do this right here, I can. There we are. So in doing that, you'll notice that the stars are a little bloated, and they're bloated differently across the image. I have very little distortion in my refractor. If I was using a reflector, I would tend to get a lot more coma at the edges. I do have some, but not a lot, as you can see. Their stars are reasonably round at the corners. But ideally what you want deconvolution to take all of that out. And the AI-based tools that come from SetiAstro do just that. They actually vary what's called the point spread function across the whole image, so that if a star looks different in this corner than all the others, it will still end up looking nice and round when the tool finishes running. So very first thing we're going to do with any image that we're processing is we're going to do deconvolution. There's a reason why you want to do that first. The reason is straightforward. It's going to take stars from the image. Go ahead. Nope. Tony, did you have a question there?
So I'm just scribbling notes at a rapid rate here.
Don't go crazy scribbling notes because the session is being recorded and it will be put up on the Halifax Center YouTube channel. Jerry?
It's good news. Thanks.
Yeah, Jerry, will we be sending that link out to all the people that have attended tonight?
We will try and figure out how to do that. I should be able to do that.
Okay. So at any rate, there'll be a link to the session. So rather than going nuts trying to scribble everything down, you'll be able to see it that way. You're also welcome to scribble it down. Now, I'm going to attempt not to get too technical in this discussion, at least at this point. My background is electrical engineering and signal processing. And in electrical engineering, the signal processing part is really the one-dimensional version of what we do in image processing. So I tend to know the math that's behind some of these things, and I will attempt not to get bogged down in it tonight. Basically, if you look at an image, and I'm just going to zoom in on a star that is not saturated. So if we look at this star is distorted. This star is distorted, and it's distorted by what's known as the optical channel. And that's a fancy term for everything between the star and the sensor. So traveling through space, the Earth's atmosphere, your optics, all form part of what's called the channel. And the channel distorts a star. It effectively blurs the star. What deconvolution does is it assumes a star is a single pixel. And it says, okay, but this star is not a single pixel. What do I have to do to this blob to try and turn it into a single pixel? And it mathematically calculates what that is and reverses the convolution or the blurring that occurred in the channel. So it sharpens your image. And it does a really nice job at sharpening it. But as I said, let me pull it up here, the deconvolution, here we go. So the tool in PixInsight is cumbersome to work with. You have to set, using another tool, the point spread function. And this point spread function will not vary across the image. So if you have pincushion distortion or you have coma in the corners and the edges, this will not fix it. You can select what algorithm you use, a bunch of noise threshold values, and then you would turn it loose and it would sharpen your image a bit. However, if you use the SetiAstro tool, which I'm just going to pull up here, and you'll have to bear with me. Once I pull it up, it's going to go to my other monitor. Oh, no, it came on this one. So this is the SetiAstro tool called BlurXTerminator. And what it's going to do is it's going to go in the image using AI, and it's going to look at the stars across the image, vary the point spread function across the image to sharpen everything in the image. Earlier, I said you want to use deconvolution as the first thing you do. The reason for that is anything that is a nonlinear process or blurring, noise reduction in other words, that you apply to this image will affect the point spread function. You don't want to change the point spread function until after you've done deconvolution. So the very first thing you do to your image is you deconvolve it. You can play with the settings, but generally speaking, sharpen stars, this just says how much you're going to sharpen the stars. And I think its maximum is 70%, if I remember right. Yeah. I generally don't go for the maximum on sharpening because I don't like what it does to the stars in terms of the star profile. We also have a setting to adjust star halos. This is an awesome slider to have in your deconvolution routine. it reduces the size of the star halos that show up like this blob on this one. It's not perfect, but it does a whole lot better than the normal deconvolution built in PixInsight. Then you can select non-stellar adjustments. So for instance, that galaxy in this image, we're going to deconvolve that. And you notice I have automatic point spread function selected. That uses the stars in the image across the whole image to vary the point spread function that's applied to the deep sky object that I want to deconvolve. And again, I can say sharpen it. I generally sharpen non-stellar things by 100%. So you just dial the slider up. There are a bunch of options here that you really don't have to worry about anymore. They were more important in the first release of BlurXTerminator. For instance, you can just correct the stars. You can correct first, then do deconvolution. You can do non-stellar, then stellar deconvolution, and you can do it to the luminance only channel. Generally speaking, I tend to leave them unchecked. And just run the deconvolver on everything. Now, I'm going to show you what it'll do here. Now, bear with me. I'm going to pull the galaxy up, but before I do, can everyone see the noise that's in this area of the image? I'm hoping that's coming across in zoom. I might be able to just make that a little bit brighter. Bear with me. Come on. Oops, I have to take that off. There we go.
Blair,
Yes.
can I ask or maybe suggest something?
Yeah, go for it.
Could you show them the real-time preview and how the benefits of using that?
Yeah, I did not as of yet, mostly because unless you have a graphics processor that is supported by BlurXTerminator, the real-time preview is no faster than doing it to the image. There is something, yeah, there is something that I will show people, and that is this little function. Here we go. I can, rather than a real-time preview, I can, if I select preview up on the menu bar, I can now show a preview of just this area of the image. And if I select that, so now you're only working on this preview now, and as a result, it's a much smaller image, so things work much faster. Previews also have one other feature that is very nice while you're working. That is, if I apply something to this preview, and then I want to change the settings and apply it again, I don't have to click undo. It automatically is undone when I apply the new settings. That does not happen with the main image. If I do something to the main image and I want to say, oh, I didn't like that, I have to back it up with the undo button here and then apply the new settings. So if I go to preview here, give you an idea of what this function will do here, I'm going to just sharpen it. And this will take a few minutes, bear with me.
It might be a good time to explain those three buttons on the bottom left of the window.
That would be an excellent idea, Jerry. Thank you. Well, that's running. Oh, it's not going to take that long. This circular button here is the real-time preview that Susan just mentioned. And I will show that in another command where it is a little more useful than this one. This square is similar to the OK button for Windows users, or the apply button. And that's exactly what it's called, is apply. And it applies this function, BlurXTerminator, to a selected image. Now, I only have one image open here. If I had other images open, I may want to apply it to this image, but if I accidentally click on one of the other images and then hit this square, it will apply it to the wrong image. So you have to watch out for that. Now, this little triangle right here is the new instance button, and it is the most confusing name I have ever come across. If I want to apply this to this image, I can simply drag it to the image and it would apply it. The nice part about doing it that way is if I have several open images, then I drag this to the image that I want to apply it to, and I don't ever make a mistake of applying it to the wrong image. The other thing you can do with this is I can save these settings and come back to them later. And to do that, I simply drag an instance to the desktop. When I do that, if I double click this, so I'm going to just close this down for a minute. If I double click this, now I have all those settings back. And I might have done several different deconvolutions or a whole bunch of other operations, and I get them back just by simply double clicking what I've already dragged to the desktop. It's an extremely useful feature that I tend to use quite a bit. It took me a while to get used to it, and I'll show you how to use it with the history dialog in a while. But that is a very useful way to ensure you apply the operation to the image that you want, and also to save the settings to come back to in a little bit. Now, take a look at what this did to the image. I'm going to, where's the redo here? Okay, so here is the image before I deconvolved it. Here it is after I deconvolved it. You can pretty much quickly see what BlurXTerminator will do. You notice the stars get much sharper, but also look at the detail in the galaxy. Notice it's a little blurry through here. Once it's been deconvolved, now look at it. I'm hoping that's coming across on Zoom. So it is worth every penny of the, what, Jerry, almost $100 for BlurXTerminator? He's going to
I
quit
think
to
that's
check
a little generous, or you're underestimating it.
You could be right. It's somewhere around that, and BlurXTerminator or Noise Exterminator, I think, is 50. Those are US dollars, of course.
Something to
Cheers.
mention about the SetiAstro features. Once you bought one of them, you're automatically given a credit towards another, like 10% off or 15. I can't remember what it is, but
Ooh, I wish they had that when I bought them.
really?
Yep.
Huh.
That's excellent to hear that.
As far as I remember, like that's, so I bought size BlurXTerminator, Noise Exterminator, StarXTerminator. I always had a certain percentage off. We'll have to go to the SetiAstro website to look for the particulars.
I'll have to go look into that. That's good to know. But it is worth every penny for those that haven't got them yet. Just because it is so easy to use compared to using the native tools built into PixInsight, and it produces stunning results, as you can see. I mean, this is still a linear image. If I turn the screen stretch off, that's still pretty much black. But you get the idea that this tool does wonders. It does take a while to run. So it didn't take long because we're only looking at a small part of the image. If we now go back and apply that to the image as a whole, I'll give you an idea of how long it takes to run here while it's crunching. So we're going to run this now on the whole image, and you can see what happens. I'm assuming you folks can see my mouse down here where it says processing. You can see this is going to take a minute or two. So while it's running, I'll point out a few more things here. The preview that I selected comes off this, unfortunately it's running now, so I can't change it, but it comes off, you pull a preview off by selecting right, where'd it go? Right here, the preview cursor. So you click on that, then you can just drag a preview on your window, So you can look at some area of the window that you want to see what your processing is going to do. And as I said, the nice thing about preview windows is you don't have to undo anything before you try something else. So for instance, I could do a stretch with a curve and say, I didn't like that. It didn't turn out well. I can go and change the curve and just reapply it, and I'll see it as if it were the only thing done to the image. You have to, once you do something to a preview, if you want to keep it, you have to lock it. It's one of the other buttons up here, which won't highlight now that it's running something. So you can, do multiple things to a preview, but you have to apply it to the preview and then lock it. Otherwise, when you apply something, it will undo the previous thing and then do what you're doing next. So you can see this has made it all the way up to 36%. For those that have graphics cards, you would be finished about now. I said graphics cards, compatible graphics cards. PixInsight is only compatible with NVIDIA cards, not with Intel graphics. So this will take just a minute, maybe a couple of minutes. But there are four tools that you will find very, very useful. One is the tool we're looking at right now, which is BlurXTerminator. The other one is called NoiseXterminator, which does wonders for noise in your image. Another tool that is extremely useful, depending upon whether, and it's another AI tool, you can get StarXTerminator, again from SetiAstro. It's very useful for separating stars and deep sky objects and background out of your images. StarXTerminator, of course, is a tool that you pay for. There's another AI tool called StarNet++, which does the same thing, but it's free. Installing it is a little different, but there's lots of documentation to walk you through installing StarNet, and it's what I use for separating stars out of my image. We'll wait here. This is over halfway done now. The fourth tool that I find exceedingly useful is another free tool, and it was developed originally by a member from Victoria, if I remember where Dave is from, and written by, I forget the gentleman's name, Michael something, but it is Generalized Hyperbolic Stretch. PixInsight comes with a stretch called the Histogram transfer function, I believe. And it is basically the screen transfer function applied to your image. It's a very good tool, but it is nowhere near as flexible as Generalized Hyperbolic Stretch. There's now a new stretch tool that PixInsight has come out with, which is almost fully automatic, which is quite nice. What's the name of that new tool, Jerry?
Multiscale.
Thank you. Multiscale Adaptive Stretch. And it's a useful tool. Again, I don't find it as useful as GHS, and I'll show you why in a couple of minutes. Okay, so now you can see this has now, I'll get rid of this preview. So this has now applied sharpening to our whole image, and you can see the effect. If I undo that sharpening, you see the stars get quite bloated. We redo that sharpening, and we've now got a very nicely sharpened image. The problem, or the next problem to sort out, and I'm having a little difficulty resetting my screen stretch. I'm not quite sure why it's not resetting for me. I may just have to do it the hard way. There we go. And it's still not going to do what I want. Try that. Okay, we'll cheat. I'll brighten it up this way. We want to reduce this to about there. Bear with me. I just have to tweak a couple of these back to where they were. Reset them. There we go. There we are. Okay, so now if we take a good look here, this image has now been sharpened, and you can see that the galaxy is quite sharp. But you can see the noise that is now quite visible in the image. Sharpening will always bring your noise floor up. But you can see something else. There's a gradient in this image. You notice it's red on this side. It's kind of bluish green on this side. Is that coming across to Zoomland? So there's a variety of ways of taking that down. There's an AI-based tool called Grexpert, which does a wonderful job, again, free. There's a tool in the SetiAstro suite called Automatic DBE for dynamic background extraction, and that works quite well. Bob Russell, I see he's there. How's Ottawa, Bob?
Cloudy right
But Automatic DBE works quite well. There's also a tool called Gradient Correction. And that's one of the standard tools now in PixInsight, along with Multiscale Gradient Correction. This one uses, in a very cumbersome way, the Mars database. This one will access it if it's available, but it does a wonderful job mostly at its defaults. You can play with these values, and if you want to see what any of these values do, there's even some documentation for this tool, which I didn't realize was there. PixInsight, even when the tools aren't documented, it tends to have documentation built in the help tips, so it's worth hovering over and reading the help tips. But basically, what's going to happen here, there's something called structure protection. And what structure protection does is it will prevent dark rings around things like this galaxy. You can try it without first. If you don't need it, don't use it because it does interfere a bit with the gradient correction. You can turn on automatic convergence, so the system will go through a variety of iterations until it gets to the final stage where the gradient is removed as much as it can. And then you can set a variety of thresholds, and you can see what these mean as you go through. It's a multi-scale tool, so here you can set these wavelet scales. Is it wavelets? Yep. But interestingly enough, if I just run that with its effectively default settings, turning on structure protection and automatic convergence, watch the job it will do. And it runs fairly quickly, as you can see. It's got to run on all the channels, so it'll run 3 or 4 times. Now look, gradient is, for the most part, gone. And undo it. You can see the color gradient. Redo it. You can see the gradient is virtually removed. If we zoom in now, you'll notice there's still lots of noise in the image. The next thing we have to do to this image is to color calibrate it. Now I have to check one thing on this image. Bear with me. Yep, it's been plate solved. Okay, this is going to be interesting to show. If you turn on, you can select, when you move your cursor across the image and you hold the right mouse button down, or sorry, left mouse button in Windows, you get this little zoom dialog, and it shows you a bunch of things about where your cursor is in the image. So you can see the X and Y coordinate, you can see the RGB values, the luminance value, and right ascension and declination if the image has been plate solved. If it hasn't been plate solved, you won't get right ascension and declination. So it's a quick way to see if you've had a plate solve on the image. You can turn on various things just with this button down here. For instance, readout data, you can select what's included in that little window that you saw. I tend to show RGB and L for luminance. You can use different color spaces. You can include alpha channels, all that sort of stuff. You have readout mode. Now, what the readout mode does, if you look at the probe size, right now I have it set to a single pixel. If I set it to 9 pixels, now when I see the brightness in those channels, what that is the average of all of the pixels in the pixel size. And it's average because I've selected mean. I can show the median or the maximum and minimum as well. The other thing you can set, for instance, is if your images are 16-bit, you can say, just show me it as a 16-bit integer, as opposed to the native normalized values that PixInsight likes to use between 0 and 1. You can, in terms of celestial coordinates, once the image has been plate solved, you can show equatorial coordinates, ecliptic, galactic, and you can then specify how to display them. Degrees and hours, degrees, hours, and minutes, or degrees, hours, minutes, and seconds. And you can select whichever you want. And again, that just, I can't point to it. I would desperately want to point with my finger to the screen, but you won't be able to see it. And if I move my cursor, it will just move the window. But you can see the 2 bottom entries there, right ascension and declination. I have hours, minutes, and seconds, or degrees, minutes, and seconds turned on. Now, in order to plate solve the image, this one has already been plate solved, but I'll just give you an idea of how to do that. You come to Astrometry, Image Solver, and you can do a search. Generally speaking, if your image has if your imaging software rather stores the coordinates of the image, they'll be here. And if not, you do a search. You just click search, type in the catalog number, NGC, whatever, and it will pull up from an online database the object. You click OK, and it will then fill in these values of right ascension and declination. It is important for the plate solver that this coordinate that's shown up here is in the image frame. If it's not in the image frame, your plate solve will fail. So you do have to get the correct coordinates in this dialog. You can either, if your software like mine puts it in, that's great. If not, you have to search it in the database. The database that it's going to use for a lot of its work, you specify here. Now, right now, I'm using an automatic catalog online. I can use my local catalog and, sorry, not local catalog, local XPSD server. In this case, is the Gaia catalog. And then I can plate solve using the Gaia catalog. If I don't have an internet connection, I tend to use the Gaia catalog. Occasionally, I won't get a decent image solution, even though my image should solve, and I tend to then go to the online catalogs and use either the BrightStar or the Tycho 2 catalog. By doing that, it'll cut down the number of stars, and sometimes you get better luck getting a image solution. Now, someone asked what to do if it doesn't solve. And aside from getting frustrated, what you want to play around with is the advanced parameters. Here you can set the scales for star detection. You can set minimum structure sizes, hot pixel removal. The one that's quite useful is noise reduction. If your image is too noisy, it won't plate solve, so you may want to turn that up a little bit. You can play around with the sensitivity setting. Generally speaking, if you dial this up, it is more likely to solve. Peak response, what this is looking for is stars with good Gaussian-shaped peaks. The peakier the star, the easier it is to recognize as a star. So you can dial that up or down, and the help information shows up just when you hover over there. This is the bright threshold, maximum distortion allowed in a star, all that sort of stuff. Basically, that's what you play with when the image will not solve. And it is a little bit of trial and error. Generally speaking, dialing in a little noise removal and dialing the sensitivity up will let it solve. Not all the time. Sometimes you have to vary the brightness thresholds for the stars, but generally speaking, that's all you really need to do. Again, if you click OK, it will go away and solve the image. This image is already plate solved, as you can see, because I get a right ascension and declination display. Since it's been plate solved, I'm going to use a color calibration method that works on plate solved images. SpectrophotometricColourCalibration. That's a mouthful. What this is going to do is going to go to the Gaia database, because I've got it selected here, and it's going to compare these stars to the stars in the database, and it's going to attempt to make all the stars it can find in this image match the colors that are available in the database. So it's actually a pretty good color calibration tool. It has some drawbacks, and one of the biggest drawbacks is when it comes time to see a galaxy in the image, it's not a star. So if there were no stars across this galaxy, it might not get the color exactly right there. That's where this white balance comes in. This is an average spiral galaxy white balance. This particular galaxy happens to be an SAB galaxy. It's right in between A and B. And you can select down at the bottom SO, SA, SB, SC. These galaxies are a little bluer than these galaxies. So I'm going to select SA. I could have left it at average galaxy and it'll do just about as good a job. Not quite, but pretty close. And there's some really good tutorials on this tool on the PixInsight website. The PixInsight YouTube channel, I should say. You can select the QE curve for your camera here. I'm just going to use the ideal curve, my actual actually, I'll use my camera's curve. There we go. And you can select whatever filters you've used here. Again, I have a Sony sensor, and these filters cover mine quite nicely. You don't need to have generate graphs turned on. I generally do simply because it's a really convenient way to see when the tool finishes running. For those that haven't used this tool, if your image happens to be pretty close to being calibrated, it may not look like it changed at all, and you may not know the tool is actually finished. So I just tend to leave generate graphs on as an easy way to see that. So if we click this, it's going to run through and crunch. And when it finishes, it won't take that long. It's going to calibrate the color of every star in the field that it can find a match for in the database. And that will also calibrate the background. Notice I've got background neutralization checked. If you want to pay particular attention to some area in the image, you can, once this is done here, bear with me. Okay. You just have to redo the screen stretch once you've done that. There you go. If you had wanted to sort of say, okay, I want this area right here to be black, all you do is you make a preview of that area, and I've got to find my preview cursor. There we go. Let's say I had wanted to make this area black. I draw a little preview, then I can drag this preview. Oops, sorry. Highlight that. I can drag this preview here. Okay, once it comes up, right to here. Oh, I didn't turn on region of interest, sorry. There we go. I can now drag that preview here, and it will automatically select that area. You notice it filled in the coordinates for the preview here. You don't have to do it that way. It's just a very convenient way of doing it. So now if we look, here is our color calibrated image. And when I say color calibrate it, within reason. Now, when you look at this image, it has now been gradient corrected, it's been color corrected, and it's been sharpened. The next thing we want to do after that, remember this is, I better mention one other thing that some of the people that aren't familiar with PixInsight may not know about. Is everybody familiar with the concept of linear versus nonlinear images? I haven't heard anybody say no. For those that are new to PixInsight, a linear image is an image that has not been non-linearly stretched. To give you an idea of a nonlinear stretch, I'm just going to pull up a curve here. Bear with me. And of course, it's on my other monitor. Here we go. So this curve, if I make this line nonlinear, that will apply a nonlinear stretch to my image. The image as you see it right now is still in its linear form. That's important for deconvolution. Generally speaking, you also want to do color correction and at least a first pass at gradient correction before you make the image nonlinear. So we've done all of that. The one last thing we have to do is noise reduction. And I'm going to show you the other SetiAstro tool here. By the way, I do not get paid by the folks from SetiAstro. They just make a wonderful tool set. And okay, I'm going to close down some of this other stuff because it will get confusing. Here is the SetiAstro tool Noise Exterminator. Now, there are a variety of ways to use this. The way I generally use it is I separate the amount of noise reduction I'm going to apply to the intensity or the luminance channel and the color channel. I do that because if you look, the thing that's most annoying in this image is the color noise. You'll notice you've got red and green blobs throughout here, and that is really annoying to the human eye. So I tend to try and noise reduce that more than the generic brightness of the image. There's another setting here called iterations, and that may or may not show up in your tool when you first open it. You have to select the latest version 3 AI in order to see that. It's available in the tool. You can either use version 2 or 3, but version 3 gives you this additional setting called iterations. The higher this setting, the slower the tool runs, but what it does is it does a better job of hanging on to faint detail while removing larger noise blobs. There's another setting here called frequency separation. I don't generally use this, although it can be quite useful in some images. What it lets you do, it lets you apply a different amount of noise reduction to the high frequencies and the low frequencies in the image. Now, to those that are new to image processing, you can think of high frequency and low frequency as how fast data in the image changes. You will notice this noise in here is changing virtually on every pixel. That's high frequency noise. There is lower frequency noise in this image that it's kind of hard to see it because I have so much high frequency noise, but that tends to make blobs in the image. If you've got an image taken with a lot of light pollution, you will get large blobs in the image. That is a much lower frequency noise, and you can correct those using this tool in differing amounts. That can be useful. I tend to find that the simple intensity color separation works well enough that I don't generally go and worry about separating out different spatial frequencies. Now, what I'm going to do here, get rid of this preview. And I'm going to make another preview just around the galaxy again. And I'm going to include enough of the background that we should be able to see the noise. Now, can everyone see that noise in this image? Is that showing up okay?
Definitely.
Okay.
Yep.
So I'm going to give you an idea. I'm going to reduce this to one iteration simply because it runs much faster, no other reason. And we'll look at the preview here, and I'm going to run this tool. Now, I'm taking the noise down by 97% in the intensity channel. I might want to do that a little less, but I'll leave it at 97 for now. And I'm taking down 100% of the color noise. And watch what this tool does. It does an absolutely wonderful job at reducing the noise in your image. Look at the difference. So here is the noisy, oops, try that again. There we are. Here is the noise-free version. See, all the noise that was here is gone. Here is the noisy version. Wonderful. It takes out my preview. Oh, I know how I can show it. Never mind.
You need to use the back
Preview
button on
back
the
and
pre.
forth.
Yeah.
Yeah,
Yeah.
there we go. So if you take a look here, here's the noisy version. Here is the noise-reduced version. You can see the difference in there. You will notice too that the AI tool has not blurred the galaxy core. You notice all the detail in the galaxy core is unchanged. So in terms of noise reduction, there are tools that PixInsight has that do a very good job at noise reduction, but they do not hold a candle to NoiseXterminator. And you can see the results. You get a wonderful galaxy image. You get something that is very smooth in the background. And it's just a wonderful way to take noise out of your image with very little effort. Literally one or two clicks of a button, or sorry, one or two clicks on a slider, and then click the apply button and go away and get coffee and come back and it's done. If you have a graphics card, you won't even have time to put the sugar in your coffee. So now we're going to apply that to the whole image. This will take a little time to run, time meaning, 4 or 5 minutes. Get rid of that preview here. It might not be too bad because I'm only using one iteration. And while this is running, if you folks will excuse me for 1 second, I have a dog whining upstairs. I think he wants to go to the bathroom, so I will be right back.
So are most people keeping up to this then, or some people think that they would need to go over this a bit more?
It's good for me.
Good.
Good here,
good.
Jerry.
Good. So as we said, there will be, unless I make a mistake, there will be a video recording of this subsequently, which I tend to go over quite detail. And what did he do there? What did he adjust that to? It's very instructive after the fact if you can't quite keep up.
I apologize for that. He did not want to go to the bathroom. He had managed to lock himself in the bathroom. He was wanting to get the door open.
Blair, question.
Yep.
You earlier mentioned that you were going to not use the real-time preview because of speed considerations.
Yep.
However, had you used it, you would have been able to get, I expect, the same result that you did in less clicks. Am I correct there?
Quite likely. At least if it were a tool that I tend to adjust the sliders more. I have figured out what seems to work well with my camera, and I don't generally adjust these too much. Oh, there, finally finished. We will look at the real-time preview in just a minute because it's the next tool that's coming up. But the AI-based tools on my computer, because I don't have a compatible graphics card with the AI toolset, tend to run a little slow, as you see. Not outrageously slow, but a little slow. It tends to make the real-time preview a little cumbersome for the AI tools only. For all the other tools, I use the AI, I use the real-time preview. And
Okay.
I'm about to show that right now. So here we have an image, and it's still got the screen stretch applied to it. So if I turn off the screen stretch, you can see the image is quite dark. And it's been sharpened. It's been color corrected. It's had its gradient removed. And it's been noise reduced. And it's actually, so far, not too bad an image. This stuff you see out here and over here, that's actually foreground gas and dust in our galaxy. It's not a gradient in the image. Now, the next tool we're going to look at is, again, developed by a gentleman. He's an RASC member on the West Coast, and it's Generalized Hyperbolic Stretch. But before I look at that one, I'm going to show the standard tool that PixInsight has. It's called the Histogram Transformation. There are many stretches in PixInsight. This one is sort of the go-to tool for a lot of people because it's relatively easy to use. You select your image here, and I'm just going to turn off the screen stretch. You turn on the real-time preview. Now, the real-time preview will update in real time as I slide sliders along here. And here, all I'm going to do, this is the black point. Oh, I better zoom in just so people can see here. One sec, where's the zoom button? So the histogram for this image is right here. And you notice it's all jammed right down against the left-hand side. For those that aren't familiar with the concept of a histogram, this x-axis is the brightness value. The y-axis is the number of pixels at that brightness value. It's a standard tool in statistics, and it also comes in very handy for analyzing your images. So when I look at this, I've zoomed in here now, you can see the histogram is all down at the black end, which you can see the image is quite dark. But one of the nice things about it, if I shrink that back down, here's the black point of my image. Here is the white point of my image. And this is a nonlinear exponential scale in between. So I can slide this down. And when I get down here, you will notice the galaxy, whoops, starting to show up. And if I zoom in a bit, I can, oops, let's zoom out. So now I can brighten this galaxy up like so. You can't directly zoom in on a real-time preview. I can change the size of the window, and that will zoom in a bit. I can, however, use this tool, which selects a preview portion. Oops, try that again. Click on it. And now I can fill the real-time preview with the galaxy. If you have a mouse or a trackball, that has a third button, whether it's the wheel on a trackball or a third button on the mouse. That third button allows you to do the same thing. I can just push the third button and draw a preview. So it comes in handy that way. So now you can see, I can start to see this galaxy. And if I click apply or drag that over, it will apply that to the image. The problem I find with this stretch is it doesn't hang on to color well. You will notice the galaxy is not particularly colorful. You will also notice that the larger stars, if I go over here, are really starting to bloat a lot. And the more aggressive I am with that stretch, the more that star is going to bloat. And even some of the other stars are starting to bloat now. So I tend to find that the histogram transform tool, although good, is not quite what I like to use. The reason being its effects on color and star bloat. The tool I tend to use is a free tool. You can download it for PixInsight, called Generalized Hyperbolic Stretch. And we'll take a look at that tool as soon as I bring it from my other monitor here. And open up again a real-time preview. So now I can zoom in to see the histogram. Here's my red, green, and blue histogram, as you see. I can view the histogram in a log format, which is what a lot of people are familiar with, or a linear format. And I can do a couple of very interesting things with this tool that I can't easily do with the histogram equalization tool. One of the things I can do, if you picture an image adjustment, and I'm going to pull a curve up here just to show you what I mean. Okay, if we take a curve adjustment, generally speaking, the curve you apply to an image looks something like that. So you are brightening up this area. This is the dark background, and you're dimming that down. And you're applying a maximum stretch, where the stretch is the slope of this line, if you will, here in the middle. Those points are not easily adjustable in the native tools that come in PixInsight, but they're extremely adjustable in a generalized hyperbolic stretch. So this tool here, which is the symmetry point, that is the point of maximum contrast enhancement. So in this curve, it will be the point right here where you're applying a maximum stretch. You know, if I make this very gross by doing this, you can see that the curve is at its sharpest in between here. And you can adjust that with this tool. Not only can you adjust it, you can, if you turn on a screen transfer function, you can select what brightness level you want that to happen at by clicking on the image, whether it be the real-time preview or the real image. So for instance, if I want to, I'm going to just zoom in a bit here, bear with me. If I want to apply maximum contrast boost to this dim spiral arm coming down here, all I do is I click on that point, a point, not a star, but a point in between the stars here on that faint spiral arm. And you will notice this yellow line that appeared. That's the brightness level where that point is. Then I send it to the symmetry point just by clicking this button. You'll notice it fills it in down here, it fills in the brightness value. Now, if I turn off that screen stretch, I'm going to do one more thing here. I'm going to select color rather than RGB. By doing that, I hang on to the color in the image, and I can actually control the amount of boost in color. You'll see that in just a minute here. Remember how flat the image looked in terms of color when we used the histogram transformation tool? Now we're just going to dial up the stretch factor here to brighten the image. And you'll notice it getting brighter and brighter and brighter But look at the core of the galaxy and look at the hydrogen alpha regions. They're all visible now. I never had to boost color at all. There they are. And I can dial that up further and further. I won't go too far here. And you will notice that the stars aren't as bloated as they were, but I can improve that even further with the local intensity slider. Now, what the local intensity slider does, if you remember that curve that I showed earlier, this sets the slope of that curve. So if we zoom out a bit here, 1 second. Maybe a little too far. You can see here's the point of maximum slope of the curve that I'm doing. As I slide this local intensity slider, you can see what happens. Right, so just looking at this curve, you notice it's steeper there now than it was. But also look at what it did to the image. Right, here is, sorry, I'll reset that. Here's 0 for that slider. As I slide it to the right, I recover detail in the core of the galaxy at the expense of having a really crappy looking star profile. You notice what's happened is it's shrunk the area of maximum brightness in the star, and you get this ring of color around the star. Generally speaking, that sort of look to the stars gets frowned upon. It tends to look kind of cruddy as the image gets further and further stretched. There's a simple way to avoid that, and that's the next tool set that I'm going to give you a quick look at. And we'll do that before we stretch the image. So here we are, the unstretched image. I'm going to turn the screen stretch back on. And what we're going to do, we're going to take the stars out of the image. I'm going to use a tool called StarNet. Some people use StarXTerminator. Both work quite well. As I understand it, StarXTerminator works a little better on removing halos around bright stars. But StarNet is free. And it would have to work a lot better to overcome being free. So here, this is linear data. So I select linear data. I'm going to select to create a star mask. It's a poor choice of words. It's going to create another image that is just the stars. If I let that run, it will take just a minute. It is an AI tool. By the way, for those that aren't using PixInsight, StarNet is available, at least it used to be available as a standalone tool. I don't know if that's still the case for the latest versions, but at least the older versions, you could download a standalone tool that you could then use with anything. And this will take just a minute, and it will then give us 2 images, one of just the stars, one of the galaxy and all the background gas and dust. Then we can stretch them differently. So we can stretch the galaxy to get a really nice looking galaxy, lots of detail in the gas and dust in the background. And then we can stretch the stars differently to avoid that crappy looking star profile. It's about halfway done now. And you can do this in other packages as well. Cyril allows you a plugin for StarNet. You can use the standalone version with Images Plus. Images Plus has its own star separation tool. It doesn't work as well as the AI-based tools in most instances, so I tend to use StarNet. And about coming up on 3/4 of the way done.
Blair, you haven't mentioned SetiAstro much. Do you use SetiAstro or any of its tools?
I do, and you're going to be a step ahead of me here. We will use SetiAstro coming up in just a minute. I just have to get past the linear portion of the image processing. So we've done all the linear processing. Now I'm separating the stars and the galaxy. There we go. So here is just the stars right there. Here is the galaxy. There are a few halos left over, you will notice, and I'm not going to bother taking those down tonight in what we're doing. That will be the topic of another session coming up, but we'll leave them in there for now, and we will get some halos around the brighter stars when we're done. But SetiAstro will be used in a minute to grab a mask, for example, using the Fame script right out of here. And we will further take down a gradient that you can just barely see in this image now. It's a little redder on this side than this side, and we'll use SetiAstro for that as well. SetiAstro, for those that aren't familiar with it, the gentleman that runs that is doing a great service to the community, providing a lot of scripts free for use, and he's got some good ones. So now what we're going to do here, we're going to come back to this tool. I'll reset it for a moment. Now you'll notice that the red and blue histogram is here and green is now up here. That's a function of the fact that I've removed the stars. You do not want to line those up. You could if you want it using this tool, and I'll show you how to do that in a minute. But you don't want to at this stage. Basically, what you want to do is simply turn on color. And going to do the same thing. We're going to pick this faint spiral arm coming out here. And we'll use that as the symmetry point. So now I've set it. But by the way, you could do that manually too. You can just click on a point in the image and click send to SP, and it will send it down here. Generally speaking, I click on some detail in the image that I want to highlight. Now we're going to turn on the real-time preview, and we'll turn off the screen stretch. And now what I'm going to do is slide this slider up in color mode. And we'll slide it a little further than we did before because we're not really going to worry about making the stars look crappy. We'll slide it up enough so we start to see all this detail in the background. Then we can take the local intensity, and what we're going to do here is you'll notice that it dials down the brightness in the bright areas of the image, but leaves these dim areas looking quite detailed. And if we zoom in on the galaxy, you can see all sorts of detail in the galaxy core. You can fine-tune all of these sliders. This fine adjustment allows you to ever so slightly move the symmetry point or whichever of the other sliders you wish to adjust. So we're going to just slightly increase the symmetry point just to darken the image ever so slightly. There we go. And we're going to work at getting as much detail in this core area as we can. Ooh, a little too bright. That's not too bad. And there is another technique that will let you get the best of both worlds that I'll show in another session. Okay, so there we are there. We've got some decent galaxy core data, or detail rather. We still got all the gas and dust out here. But look at the color we've got compared to the stretch, compared to the histogram transformation tool. If we zoom right in on this galaxy, look at the H2 regions, look at the red in the core, right? And the nice part about this is sometimes this will look a little oversaturated. That's the purpose of this slider right here, the color mode options slider. I can dial down the amount of color boost or that I'm seeing in that image. I can set it to wherever I want it. Generally speaking, I leave it up near that end because I tend to like colorful images. But now you can see that's not looking too bad for a galaxy. That's just one pass with this tool. So now what I'm going to do is I will apply that to the image, to the galaxy image. And here is our galaxy image that is no longer in linear form. It has now had a nonlinear stretch applied to it. And the background is just a little bit bright for my tastes. Now, one thing this tool lets you do, it has another stretch mode, which is linear. And here, I can set the black point. Oh, I better turn on the real-time preview. I can set the black point. I can set the white point. If I can grab it. As you can see, it clips the white point, wherever that is. But I don't generally do that too much. The reason is, as I slide the black point slider, where did my arrows go? Zoomed. Oh, just a bit. There. If I adjust the black point slider, I have a potential for clipping data. So for instance, you would think I could slide it all the way over so it's right at the foot of the histogram. The problem with that is that this histogram is displayed linearly. If I do it in a log format, you notice I've clipped the black point. Clipping the black point is something you want to avoid because it will lead to some image posterization. It'll also lose you some of the dim data. A nice way to avoid that with this tool is to do this. We leave it in generalized hyperbolic stretch. We're going to set the symmetry point well below the image, and you can actually go to a log view and set it down at the bottom of the log histogram. Then what we're going to do, send that down to the symmetry point adjustment, and we're going to slide this slider, which is protecting the highlights, all the way down. It will stop when it hits the symmetry point. Now, when I try and stretch the image using this slider, it doesn't stretch it, it moves the whole histogram down. But I can go all the way if I want, and it will not move that down enough to clip the bottom. So I can make fine adjustments to the background in that manner and never worry about clipping the black point. Comes in very handy when you're messing around with an image like this. So there I've now reduced the black point, potentially a little too much, but you get the idea. So if I dial this up just a bit, there. Now you can see we've got decent black points. We've got all sorts of gas and dust in this image and all sorts of detail in the galaxy. At that point, I would apply that to the image. Here's our image. Then go back to the star layer. Now, the star layer at this point in time is still linear. So if I take the screen stretch off, you can see it's linear. We're going to apply, again, a generalized hyperbolic stretch, but we're going to do it in color mode to preserve the color of the stars. So you get very colorful stars. But we will not set a symmetry point. We'll leave it at 0. And that's very important to leave the symmetry point at 0 for stretching the star image. As we slide this, I better turn the real-time preview on. We'll slide this up. And what I'm going to do, I'm just going to zoom in. Now you'll notice the star profile didn't take on that really messy look that we had when we tried to do it as one complete image. That messy look you get when you start sliding this slider over. It's necessary to slide the local intensity slider over to get galactic core detail in the galaxy, but it destroys the stars. So what you tend to do is you only want to slide this over a little bit just to get color in the stars the way you want. That's not too bad there. And then we can apply that to the star layer. So now we're stretching the star layer differently than we stretched the galaxy. Here's my star layer now. Now we can recombine the stars with the galaxy and see the result. There's a variety of ways of recombining. They all use PixelMath for those that aren't familiar with the process. But the one that I tend to use, there's two that I tend to use most often. The one that I use the most often is a screen combine. For those that aren't familiar with a screen combine, PixInsight doesn't have layers, so it's using two different images as if they were layers, so to speak. And a screen combine is just accessed. I normally just type it in, but I'm going to use the expression editor just to give you an idea. Under, not operators, sorry, generators. Combine is under generators. You just double click combine and it goes up there. You have to open the parenthesis. And your images are here. So the star mask is the star layer, and the galaxy is the integration auto crop. The names are up here. I tend to like short file names simply because I hate typing. So what I do before I do anything, I just change the name of the file. It's not change, I shouldn't say of the file, of the view that's here. And you do that just by right-clicking the image, go to Identifier, and you can type in whatever you want. So for the galaxy, I type G. For the star layer, oops, I duplicated it. I didn't want to duplicate it. Identifier. I just type S. For no other reason other than I hate typing long file names. The expression editor can get around some of that, but the expression gets very long if your file names are long. So I just tend to make them short. So we'll combine. Now, one other thing, I can use, rather than using G for the name here, if this is the current highlighted image, I can use $T, and that applies then to any highlighted image. It's just a function of PixelMath, but I'm going to use G just to make it obvious. And by G with S, and I'm going to use a screen combine. You can find all of those under the expression editor. So for instance, if you go to functions and you scroll down to all the op modes, you can do, all the things you're used to in Photoshop. You can do color burn, color dodge, difference, exclusion, hard light, soft light, all those. And screen is one of the modes that you can choose. The reason for using a screen is effectively what it's going to do is where S is brighter than G, it's going to put S in. It's not going to put as much of S in when the stars are dimmer than the background dust. It will put them in. You will still see the stars, but they won't saturate because of the brightness of the background dust, which is why I tend to use a screen combine. There are other ways of doing that. The problem is all the other ways do clip bright data. This doesn't. So the next thing you want to do, I usually generate a new image just so I can see it without losing either of these two images, because I may want to go back and change them and then recombine them. So if we do that, now we have an image that is our galaxy and the stars. We don't have a lot of star bloat. We've got a nice colorful galaxy. And we have colorful stars. Oops, wrong button, sorry. So you can see all the red stars in the image. We've even got, like this galaxy here in decent detail with a little spiral arm sticking off. There are others in the image as well. Most of the stars are well controlled. As I said, there were a few halos, you can see them in this image, that you would normally clone out or use a morphological transform and just erode them away. But for now, I'm just going to not worry about them, and you get a very decent looking result. Now, before we would say that's a decent result, the galaxy could still be sharper. And the way we're going to get that, again, using some of the tool set that Jerry mentioned, there are several ways to isolate just the core of the galaxy. One way to isolate the core of the galaxy is to use the mask tool, mask generation tool, and grab a range, oops, it's on my other monitor, grab a range selection. The problem with this tool, as you will see here in a minute, we'll open a real-time preview, turn on screening so I can see everything, is I'm going to get rid of the dark stuff, and then I'm going to get rid of the real bright stuff. But as I do that, I'm starting to lose, like I want to get rid of, these bright halos, but you notice I'm losing some of the galaxy. So I'm somewhat limited in what I can do with that tool. I can reduce some of that, but I'm still left with these bright things that I would then have to go and paint out, clone out. Rather than do that, we'll use one of the many SetiAstro tools that is an absolute wonderful addition to PixInsight called, it's under SetiAstro, called Fame. And in Fame, which is a freehand script drawing tool, I can now draw a mask that will just isolate the core of the galaxy. And now whatever adjustment I make to the core won't affect anything else in the image. I won't dial the noise up in the background while I do sharpening, all those sorts of things. And you literally just draw a mask. Oops. And you don't even have to worry when you do dumb things like this, because you can just go up and draw another piece of the mask right over that. And now the whole mask will be the outside edge of everything. It's a wonderful tool. You can then blur the mask a little bit right here. By blurring it, when I sharpen it, it'll sort of blend in better. Click execute, close that, and now I have a mask right here. It's a great tool. It breaks the rules that the PixInsight developers originally intended. They don't like drawing things on images. It comes down to the fact that their background is scientific imaging. Most people that are using, taking their own astrophotos, they seem to be much more interested in pretty pictures rather than scientifically correct images. I do a little bit of both, but certainly tonight we're looking at pretty pictures. So using the Fame script allows me to make a mask very quickly that will do what I want, and it doesn't require me going in and painting out all of the star halos. So if we take this mask done with the SetiAstro scripts, we're going to apply it to this image. And all you do to apply it is you grab the image label here, and you drag it over to the image label here. That mask is now applied to this image. You can see that it's where it's red, everything has been masked out. So whatever I do will only affect the areas that are visible. Generally speaking, you want to, once you've got the mask covering the area of interest, you tend to turn show mask, and you just get that by right-clicking on the image, by the way. You can also click on the mask menu. So you click Mask and turn off Show Image. The mask is still there, it's still applied, you just don't see it. It makes it easier to see the transition from what you're going to do in here to what's going on out here. Now, the reason I'm doing all this, I want to get a little more contrast in the galaxy. The general tool for doing that once your image is nonlinear is local histogram equalization. And I'm going to pull that over here. Now, here we have, it's called the kernel radius, but if you can picture, think of it as, in this case, 64 by 64 pixel square. And that's going to be used to develop a histogram for this tool. You can change that value. We're going to start at 64. We'll probably go a little higher in a minute. And we'll turn on the real-time preview. And we'll zoom in, again, by just selecting a preview on that area. You can see what has happened. The contrast has been dialed way up in the core, perhaps too much. You can control that with the amount slider. All right, so if I dial this down, you can see the difference. There's that versus that. Furthermore, you may not want to affect small scale data, and you may want to affect larger scale data. You do that by changing the kernel size. So if I dial the kernel size up, you can see what's happened. I don't get as much contrast enhancement in all these small fine details, but the spiral arms stand out a little more. Finally, you can dial up the contrast limit. If I dial that way up here, that's obviously too far, but you get the idea. The contrast boost is controlled by this contrast limit. I'll dial that back down to 2. I generally leave it at 2, which is the default. And I'm going to dial this down a bit because I'm interested in some of that small scale detail. $64 seemed to be actually a pretty good value. Now, if we turn off the real-time preview, there's the original. Oops, sorry. Here is the contrast boosted version. It's a little too much for my taste, so I would tend to turn this down a bit. So there we are. There's the galaxy the way I personally like it. Here it is before the contrast is boosted. You will notice, however, that the mask is preventing that same boost from being applied to these outer arms where it would really just bring up the noise. Right? So if you look here, if you look out in this area, you'll notice there is no contrast boost out there. It's all limited to the area where that mask is applied. Now we'll apply that to the image. I'll get rid of that. It just takes a second or two to run because it's going to apply it now to the whole image, although it will be limited to the area that the mask is set for. Now we have a galaxy that's looking pretty good. It's quite detailed. You can see here's a 1-to-1, here's a 100% crop, as it were, and we've got detail right into the very core of this galaxy. We still have all this outer gas and dust here. And now we're going to use another SetiAstro tool. I have to take the mask off before I do. So all I do is click Mask, Remove Mask. And we're going to take down, you notice it's a little redder over here than over here. And we're going to take down that last little bit of gradient with the Automatic DBE tool. Now, DBE stands for Dynamic Background Extraction, and that is a process here, Dynamic Background Extraction. And what I would have to do is go along, I can either automatically generate a grid of sample points, or I can set sample points where I want just by clicking in the image. So if I sort of click that and then click here, you notice it left a sample point, and here and here. You have to put at least 4, I think, 3 or 4 points. And it will build a map of the gradient that way. That can be useful for fine adjustment, but it's a bit of a pain in the butt when you have an image that has just an easy to remove gradient. So I'm going to use Automatic DBE from the SetiAstro script right at the top, because it will build that automatically for me using a nice AI-based tool. And if you just hit execute and let it run, it only takes a few seconds. Now what it's going to do is now it's doing a gradient descent path algorithm to determine where all those points actually should go. Then it puts them there, and it does a final gradient reduction. This is a map of the background that it removed. And if you look, most of that red that was over here is now gone. And we have a reasonable galaxy image now, as opposed to this one that had a lot of, you see that red distortion throughout there? Is that coming across in through Zoom, or is the Zoom compression removing it?
Somewhat.
Somewhat coming across or somewhat removing it?
Somewhat coming across.
Okay, I might be able to make it more obvious with, no, I guess I won't. Okay, never mind. So you can see it's a little reddish here. Most of that red is now gone. Some of that red could be real. I have no way to know. So I haven't removed it all, but you could if you want it. And we're going to use this now as our final galaxy image. So I'll get rid of the other one. And I will rename this one G, just so I can reuse my PixelMath. There we go. I'm going to do one more thing to this image. Again, we're going to take a look right in at the galaxy. Excuse me, I got hiccups. We can still sharpen this a little more. The contrast has been turned up, but it could still be just a little bit sharper. So I'm going to reapply this mask. There are a variety of sharpening tools, and we will look at all the multi-scale tools in future versions of this series. But right now, we're just going to look at one tool. Just going to turn Show Mask off. That comes in really handy for giving you a very quick sharpening as long as your image is reasonably low noise. So it's called an Unsharp Mask, and it's under convolution. Again, you can get it from all processes as well. And everything is opening up on my other monitor, so I'll drag it back and I'll close down a few of these just so that it is a little more useful. Now, what we're going to do here is we're going to play around with the standard deviation and the amount to get this to sharpen up a little bit without going overboard. And just like with the tool used for local histogram equalization, the bigger this number, the bigger detail it affects, right? So we're going to start with it at 2. We'll play around a bit. So here it is applied, and we'll zoom in to have a look in this real-time preview. You can see that's kind of yucky. But if you now turn down the amount slider to, I don't know, about there, now look at the difference. A little slightly blurry, less so. Is that coming across Zoom? We can affect larger detail by turning that up a bit. And now if I dial this up a bit. So now I'm not affecting the small detail as much, but the larger detail has been sharpened substantially. And you'll see that here. See the difference? And it's a balancing act as usual. This slider right here, by the way, is a fine adjustment on this slider. You dial this slider down all the way and it will go to 10. If you want below 10, you use this slider to fine tune that. And I generally end up somewhere around there. And then I can dial up the amount. And again, I don't want to go too far because if I go too far, the image will get yucky. But you can play around with the amount to get something that looks nice and sharp, but not over sharpened. And it's a simple sharpening tool that's easy to use. Apply it with a mask, only apply it to the bright areas of your image, as we're doing here. But you can see the difference, right? We've gone from this, which is a little blurry, a little soft, to this, which is less so. Is that difference coming across there? Okay, good.
Yep.
And it's an adjust to taste type thing. I tend to like my images slightly on the softer side, so I'm just going to dial that down just a little bit. That's not too bad, right there. So we'll close the real-time preview. Oops, it won't let me at this point. I have to wait for it to finish. Did I just do something to PixInsight? We'll soon see. Okay, I got to get this window to close down. Bear with me. There we go. So now we can drag this onto the image. And there we are. There's our sharpened galaxy. Now we'll recombine that with the stars. And again, it's PixelMath. The expression is still there from the last time I used it. If I were going to type other things in here for other adjustments and then want to come back to this, that's where I would simply drag this down and then I could double click it and bring back the settings. Now, before we do, I'm going to show you one thing. You notice I'm creating a new image. If I click Replace Target Image, it will add the stars into this image. However, this image has a mask on it. So we'll only add the stars in where the mask is white, meaning it'll only add the stars back into the core of the galaxy. You get the idea. Not something you particularly want to do for your final image. You could take the mask off and do that, and it would do the whole image, or you just click Create New Image. And then it will create a new image. Now we have a galaxy that looks nice and sharp. We've got some background dust. I could dial that up more if we want it, just use another stretch. But that's not a bad image for less than an hour, or less than an hour and a bit's worth of work. So that's sort of a high-level introduction to a split star workflow and to some of the tools that are available in PixInsight. I know there are lots of tools that other people are interested in, and other things like multiscale processing, multiscale linear processing, median processing. We'll look at all of those in the future, but I wanted to give everybody just a broad overview of some of the things that PixInsight can do tonight, and some of the plugins that are available. Jerry mentioned some of the other plugins in the SetiAstro suite. There are some great tools in here. You can reduce the halos and stars. You can do a statistical stretch, which is another decent stretch to apply to your images. I tend to like GHS for most of my stretching because it gives me the most control and it gives me better color than almost any of the other stretches. With one possible exception. Do I have it here? I know I downloaded it. One sec. Yeah. what's that new stretch that they just came up with? Multiscale adaptive
Mass.
stretch. Yeah, that works reasonably well. It's probably becoming the best of the images of the PixInsight native stretches. Um, Basically, you have a couple of sliders to play with, how aggressive you want the stretch, what you want for a target background. You can select a background reference. There's a contrast recovery that's very similar to what I did in the core of this galaxy using GHS, where you are effectively setting the inflection point to try and maintain core detail. And there's a color saturation control. I just personally don't find it works as well as GHS just yet. It's getting there. It's probably the best stretch tool available in PixInsight right out of the box. Any questions on what we've done so far?
Is it time for the test now?
Oh yeah, there's a test. We didn't tell anyone about that, did we, Jared?
What did you take this initial image with? What hardware?
What hardware? This was taken with an Esprit 120 apochromatic refractor and a Zoo ASI 2600 MC Pro. So a color camera. Any other questions?
Very nice.
It's a reasonably simple workflow. It produces great results. You can, I could easily go in and dial up more detail in the gas in the background. I didn't bother tonight, but you can go nuts with the amount of stretch you apply, and still not kill the image due to noise. I haven't used any other noise reduction other than the linear noise reduction that we initially applied. And if you look, there's really no need. The background is pretty smooth. Some might say overly smooth. There is another really nice tool for nonlinear images called noise reduction. TGVDenoise, and it's really only useful on nonlinear images, so images after they've been stretched. You can use it on linear images, but it is really hard to fine-tune the values. The default values work really well for even heavily stretched images, but we'll look at that another night when we concentrate more on something simple, something like noise reduction. So, we'll do sessions where we're looking at stretching, sessions where we're looking at noise reduction, sharpening. We will do a session on as well, using some of the multiscale tools that are available. They do a really nice job. They can also be used to take down background noise blobs. We'll do a session on each of those as we go. I just wanted to do an overview tonight, show some of the tools and the user interface to PixInsight. Hopefully people have found it useful so far.
If people want to leave a note in the chat about what they might like to see or comment on usefulness, that'd be great.
Yep, that would be appreciated. That will help us to put together the next sessions. The next sessions won't be as general as this one. So I'm guessing the next one might be, we'll do a session, for instance, on the weighted batch script. It's actually fairly easy to use, provided you don't do a lot of the nitty-gritty things that you really don't have to. A lot of the settings, if you leave them on auto, it works just great. And this image, by the way, was initially stacked using the weighted batch script, weighted preprocessing batch script.
We could also email you now that you've given us your email address.
You absolutely can. Yep, either type it in the chat or just send me an email.
Okay.
Any other questions?
Thanks, Blair. Good show.
Yeah, excellent.
Thank you, Blair.
Good enough.
Thanks so much.
Well, with that, folks, I'll say good evening. And is there anyone on the list? I don't see the person I was thinking of in particular, but if there's anyone on the list that is really new to astrophotography and isn't familiar with things like image calibration, not how to do it, what it is, if there is and you want to stay on, I can go through that with you sort of as general background. Otherwise, we'll see you next time.